Assalamu alaikum. Today's class will be continuing with our examples of analytical chemistry. We were doing so for the concepts of HNMR. So, today's example, we have the data of an alcohol. It is said that this is a data of an alcohol. So often you would see they are giving data, or they're mentioning that what type of molecules it could be. While other times, like they tend to not say, but usually like, it depends on the difficulty of the question. At the same time, like it depends on where they have given the information. Sometimes they will give the information about like what type of molecule it is. At that time, they might not give the number of hydrogen and vice versa. Okay. So this information, it says we have a compound A. Okay. And let me raise this up. We have a compound A, and when this compound, like this compound A is an alcohol, okay. When this is oxidized, okay, we get a component B. Now, don't immediately have assumption, okay, since alcohol is oxidized, so it is going to be carboxylic acid, or this is like we don't know, because why? Because alcohol, there are like two types of alcohol who undergo oxidation reaction. Primary and secondary. The tertiary alcohol, they does not undergo oxidation reaction. The primary one undergoes oxidation reaction to produce two type of product, either aldehyde or carboxylic acid. Now, if heat not under reflux is given, then what happens? Aldehyde. But if heat under reflux is provided, then carboxylic acid. On the other hand, if we have a secondary alcohol, oxidation of it directly produces ketone, okay? And ketone further cannot be oxidized. Now, the graph shows we have the counts over here as 0, 1. These are the leveling, 1, 2, 3. And we have 4, 5, and goes on, okay? So I'm not drawing the, I'm not marking the rest of them. Now, they have mentioned that this is the HNMR graph of an alcohol, of the alcohol, okay? So that means this is compound A. Then we have over here, and over here, some information, okay? Now, based on this information, we are supposed to find the corresponding molecule. However, some other information is also given here. The structure of B is also provided. Like I'm not exactly the structure, it's basically the HNMR graph of B is also been provided. So after oxidation, this is after oxidation. As oxidation happens, we get this one as our molecule. So we have 0, 1, 2, 3, 4. Okay, so 0, 1, 2, 3, 4. And we'll be needing anything else over here. Now this is for HNMR for our component B, okay? That was for component A. Now here we have a reading at 2. Now some other information is been given, which is M is to M plus 1 is given as 17.6 is to 0.6, okay? That the ratio is given. Now based on this information, you're supposed to find the values or the component structure, like what is the component being given to you. So you have to identify the component A as well as the component B. Now, I would urge you to pause the video here and try it by yourself. It doesn't matter if you are able to solve it or not, but at least attempt and see how far can you like recall and how far can you like travel. If you need help, you can like go back to the notes of like previously you have taken. So based on the notes, based on the previously solved question, you can try to attempt the question. And remember, like whenever you are solving question paper, okay, whenever you're solving examples question paper, always keep a data booklet nearby you, okay? So that will make, like, obviously one thing that it becomes very handy for you to like analyze the concepts and as well as like grab the information. At the same time, you will get used to it, like using the data booklet, so you won't be in let's say in an alien situation. You won't be in an alien situation that you don't know in which atmosphere you are in. Okay, so yeah, proceed. So try it yourself. Okay, so we'll be solving it now. Now let's see what information we have been given. Since like from this information, find out the number of carbon atoms is very easy. So we'll be doing that first. So finding the number of carbon atoms, which is 100 over 1.1 times what? M is to n, m plus 1 over m, isn't it? Because whatever is given here, like remember, we need to find what? We need to do m plus 1 over m, but they have given us the opposite way. So if we want to write in their pattern, it will be 17.6 over 0.6. This means like m is 2, m plus 1 means 17.6 over 0.6. Who is towards the right? That is towards the denominator, and who is towards the left? That like resides in the numerator, okay? But we need what? In the opposite way. That means we just need to flip the values. So 100 over 1.1 into 0.6 over 17.6, which should give us an approximate value of 3. Okay. Now we got to know that there are 3 carbons in total. Okay. This is the m is to m plus 1 for our alcohol being given. Okay. Now from here we can observe what? We can observe actually we have 3 chemical environments. Okay, 3 different chemical environments that could be observed from here. So for what we can see is we have 3 carbon. We have like this carbon, like we have 3 carbon in our molecule, as well as it should be an alcohol, and we have 3 chemical environment. Let's see what each of them should represent, or what could this like peaks, like what this peak could represent. For this one, this is in the region of like 1. We know from data booklet from 0.9 to 1.7 most probably. So in that region, we have either CH3, CH2, or CH group. So that sort of groups are present. Okay. Now that means if we consider, let's say this group, the adjacent carbon is going to have how many hydrogen atoms? This represents it, like since this is a duplet, that means the number of hydrogen is what? Is 1 plus n plus 1. N is the number of hydrogen. So that means 1 hydrogen and plus 1 is the peak. So if we are representing for this carbon, its corresponding carbon should have what? 1 hydrogen. That's what it is representing. Okay. Now that went for our 2 carbon. Now we don't know how many carbon does this, like sorry, how many hydrogen does this carbon has. Okay, we don't know that because so far we have not found any information regarding that. Let's move on and see if any other information could be provided. See here we have a singlet, and we usually know that singlets are basically for whom? Due to the special groups, for example, alcohol or carboxylic acid, that sort of things. Okay. Now, just give me a second. Let me take the or bring the data booklet out so that it becomes easy for us to find. Let's see. Just give me a second. Here is my data booklet, and let me share. I think it is visible now. So see over here in the region of, yeah, for alcohol, it is in the region of 0.5 to 6.0. In this region, if we get any like singlet, that means that singlet represents an alcohol. Like so far, what we can observe is yes, that this is actually true because we are getting that. Because 0.2 is in between the region of what, 0.5 to 6, and this is 0.5 and this is 6, and in between this region, and yeah, we got a singlet. So that means so far what we can see or what we can find is this singlet is due to whom? An alcohol group. Okay, fine. However, see over here, we have a multiplet here. Okay, we have a multiplet here. Now basically don't count the number of peaks here because there should be 2 more peaks here. Yeah, 2 more peaks should be here. But yeah, whatever it is, consider the number of peaks here. Okay, now what we can say? We can say since this is oxidizing, that means this is a obviously primary or secondary alcohol. The primary secondary alcohol it could be. So we don't know if this is in the first group or the second group. Like since we know it can be a tertiary alcohol. So thinking of an alcohol in the tertiary sector is like impossible. But so far that's what it is. Now we cannot get any further information from the above graph. Why? Because we don't know how many peaks are there. Okay, don't count the number of peaks here because I might have drawn it here like to make sense that okay, that much of peaks are there, but like when like observing the graph, oftentimes you will see okay, it's not visible. Like you cannot understand how many peaks are actually there. Okay, if that's the case, if you can't understand how many peaks are there, and if information is given that after oxidation we get this is the scenario, then let's see what after the like oxidation what happens. We obviously know after the oxidation an alcohol, the number of carbon does not change. Okay, that means the number of carbon will remain same. But see, after oxidation, the number of environments became what? It reduced to 1. Previously it had 3 environments, but now it has what? Just 1 chemical environment. That means the environment changed. Now, in which condition the environment is going to change? Let's see. Now, we have the information so far. We know there are 3 carbons. Okay, 3 carbon atoms are going to be. Let's see what sort of examples can we make. We can have an alcohol over here. We can have an alcohol of such. Okay, these are the 2 possible alcohol we can have for a carbon of 3 carbon atoms and a primary or a secondary alcohol. This is a primary alcohol and this is a secondary alcohol. Now, in each of the case, if we oxidize them, what happens? For the primary alcohol, we get either aldehyde or carboxylic acid. So if this is if it forms an aldehyde, then what happens? If this forms an aldehyde, then this should be the scenario. Okay, and if this forms a carboxylic acid, then this should be the scenario. However, for the secondary alcohol, what will happen? It will simply form a ketone. Now let's see which of this after oxidation has like just a single environment. Maybe by the time you might got the idea which one is the having a single environment. But let's see, for simplicity, for our sake, let's see what can we get from the answers. So for this one, if this is an aldehyde, see here we have a carbon with 3 hydrogen. This is an environment, and for this carbon, this is another environment, isn't it? At the same time, this aldehyde has another environment. That means we got 3 different environments. Let's come to this one. Here we have an environment for this carboxylic acid. Okay, then we have an environment for this one, like CO and CH2, and we have finally environment of this CH3. Also remember, for this aldehyde portion, we will get actually this one as an environment. Okay, this one will be an environment because C double bond O in data booklet we are given C double bond O H group. Let's see in the data booklet. Here you go. So see here CH3CO or CH2CO. So like C double bond O is present there. Okay, so that means in total that's a group. like if we have a carbon oxygen double bond, like carbon and oxygen having a double bond, that is considered as a group with the adjacent alkyl group. So this is the adjacent alkyl group, as well as this is the adjacent alkyl group. Okay, now coming back to the blackboard, we are having, after oxidation, more than one chemical environment here. However, for this secondary, see here we have an environment. At the same time, see here we have environment, but they're identical to each other. But for the primary alcohol one, if we get aldehyde or an, carboxylic acid, in both the cases we have like no identical groups, but in ketone we have identical groups, and it itself cannot represent any like further group. Why? Because it does not have any hydrogen with it, like with it. If it does not have any hydrogen with it, we are not supposed to find its environment, isn't it? Hydrogen is supposed to be found based on if and only if the carbon has a hydrogen with it. Okay, since this carbon does not have any hydrogen, so we are not going to consider that's like environment of it, but it has two unique group. That means like it's one environment. Okay, so one chemical environment, that's what it is, and that's basically for our like the CH3 group. Now how this comes, like how this makes sense, let's see. If this is our chemical environment, we have to see the adjacent carbon, how many hydrogen does it have. The adjacent carbon has how many hydrogen? 0. So n plus 1, which is 0 plus 1 equals to 1. That means what? A singlet. See, we have a singlet in between that range, which is in between 2. So that's our singlet. Fine. And for this one, if secondary alcohol is our main target, if this is our alcohol, then let's see if it makes sense, if it goes with this. See, we have a doublet here. For this CH3 as well as for this CH3, the adjacent carbon has only one hydrogen. And one hydrogen means 1 plus 1, which is 2. That means doublet. Okay, that's fine. We got a doublet. This is for CH3 group, like 2 CH3 group, 2 of the CH3 group. And this doublet is for this CH because of that hydrogen, single hydrogen to the adjacent carbon. This OH, this singlet is for this OH. Finally, we have this multiplet. For whom this multiplet is? For this carbon, let me mark with a different color. For this carbon, the adjacent carbons have in total of 6 hydrogen. So 6 plus 1 means what? 7. So that means a multiplet. So got it? That is how it gives us the answer. Now, you might be saying, then why is it not in this region? Like, why is not it is not in this region the multiplate? Why is it on that region? Because we are considering the alkyl group. But remember, let's go back to the data booklet. If we have a OH group, let's see, here we have a O group, okay, oxygen. And with that oxygen, I mean, if let's say, wait, not this one. Just a second, let me see which one resembles in a good way. Basically, they are most probably saying that, just a minute, let me see. CH3 means, or CH2 means. Okay, so basically what they're like for the reason, like for which they are like saying that our group is in that region, like we did have the singlet in the second position, isn't it? The count per second of 2. There we got a singlet for OH. But at the same time, the multiplet represents that it is with the alcohol group. It is having alcohol group, or the adjacent alkyl groups are attached to the alcohol group. See here the R group. This R group is that CH3 to the other side. Okay, so this is our OH, and this as a whole is our R group. Okay, this as a whole is our R group, and this R group lies in between this region. So in that region, actually, we got 2 environment then. One is that singlet, which is for alcohol. Another is in the 4, like number 4, like in the 4, like the level 4, we got a multiplet there. So that was actually basically for that R group. Okay. So yeah, I know sometimes it gets confusing, but I hope that's like convincing actually. Why is it the answer? So I hope now this is clear for which groups actually what are the like molecules present and who actually defines, I mean, for which type of component the values are given. Okay, so this is actually for whom the CHOH group, you can say, and it has adjacent like higher like bond there. I mean, like it has a continuing bond there. Okay, for that group it is present. Then we have the AOH, which is, I mean, sorry, this is actually for CO. Yeah, this is the case. So CHO, you can say, like HCO, you can say. So this CO means just a single oxygen, not C double bond O. So that's the alcohol's CO's part. Okay. So like this actually, I'm talking about this portion. Wait, this portion. So this COH, okay, this COH, due to this COH, this group is here. And because of the adjacent carbon and the hydrogen, we have this multiplet, okay? But the number, like the position here, is because of this COH or OCH group, okay? OCH group, okay? And the singlet here, it is for the alcohol. And finally, this doublet is for CH3, like whose environment or whose adjacent carbon has one hydrogen, that means doublet, okay? The number fixed because of the adjacent carbon. However, the position is for this molecule CH3. Okay. Similarly, in the component B, we have a ketone, and because of the ketone, like because of this C double bond O CH3 group, we have this like peak over here. Okay, this peak is over here in this position. And why the singlet? Because if you consider about the CH3, this CH3's adjacent carbon has no hydrogen. That means what? 0 plus 1, which is one tick, like one tick should be there. That means a singlet. Okay, so that's basically it. Moving on to our next example. We have, let's say, a molecule. Let's say the molecule is given as CXHYNO. Okay, this is nitrogen and oxygen present. So this is actually the molecular structure. Now the actual structure is given. And the M:1 ratio is given as 48:1.7. Same as the previous question, we are given the chart for, or the graph for the value. And we have, let's say, oftentimes you would see that there is, let's say, this slight hinge, slight hump over here. Okay, so that hump, it's not like nothing of our concern. That basically, like most probably, what how far I know it, it's most probably represents some other sort of, let's say, counts, or maybe that's a maybe some like some counts, like counts or values that there are some, yeah, like values are there, or maybe it's because of, let's say, some graphical information, or the like the characteristic of a graph. But nonetheless, we are not supposed to be concerned about this. This is not an environment. We are not supposed to be concerned with this one. Okay. Here we have 0, 1, 2, 3, and it goes on. Okay. However, in 1 we have this, and in 2 we have this. Okay. Now it's your duty to find the value of the compound. So you have to find the values of X and Y in this molecule. So you are given the structure here, with which molecule you should be finding. So they have made the task easy for you. At the same time, you're supposed to find what should be the molecule present here. Okay. Now, just a minute. Just give me a second. Okay, yeah. So I was actually, what I told, that's sort of wrong. This one actually represents a peak. Okay. So yeah, I'm really sorry. I haven't noticed it earlier. This one sort of represents a broad peak. You can say like a hump hump sort of peak. So this is a bigger peak. So this is a peak as well. 3, 4, 5. Wait. We have 5. Five here, 6 here, 7 here. Okay. So in this region, we have a picture. Now you have to find the values for whom like, these are responsible. Okay. Why, like, for which component are this like this like for which component, like, or which component are responsible for this piece? Okay. You have to find it. So try it yourself. So if you couldn't find, it's completely fine. Let's do it together. So observe here. We have let's change the color. Yeah, we have how many environments total? We have 3 environments. Okay, fine, we have 3 environments. That's really good. Then let's try to find the number of carbon here in this case. So 100 over 1.1, and we have to find m plus 1 over m, so which is 1.7 over 48. That should give us a value of 3. So this is also in this case an approximate value of 3 is being provided. So that means there are 3 total carbon numbers. That means the number of carbon should be 3. That means the value of x should be what? We got the value of x, which is very correct. That is 3. So 3 is the number for number of carbons. So we got one of the answer. Now we are supposed to find the value of H, hydrogen here. Now let's try to dive deep inside and see for whom are the like this peaks responsible for. It is so far clear that so far we like how for the time duration we have been doing such questions. This could be easily found, like say that this is actually which group. Nonetheless, let's do it manually. Here we have what? 3 peaks, and we know n plus 1 is equals to, in this case, is 3. That means n should be a value of what? 2. That means if we're talking about the carbon and whose environment we are talking about, if this is the position of that carbon, the adjacent carbon should have how many hydrogen? 2 hydrogen. Okay, that's basically what it is suggesting. Now, this was so far good about that. What about this one? Here we have a quartet here. So if that's a quartet, that means n plus 1 equals to 3. So that means n equals to, sorry, it's 4. That means n equals to what? 3. That means if this is a carbon, we are talking about the carbon here, its adjacent carbon should have 3 hydrogen. So that's what sort of it is saying. Okay. Okay, fine. That means these 2 so far we are good to go. We can also like not so far like sure like we are not so far like totally ensuring that this is the case, but we can say that they are sort of the neighbor of each other, isn't it? Because this sort of makes sense in some way, but also it doesn't make sense. Why? Because this is in the region of 2, but we know if that's the case, then they should be in the region of 1.7. Okay, 0.9 to 1.7 should be the region from 0.9, but this is more than 1.7. That means there should be some other molecule or component attached to the, let's say, the CH2 group. Okay, if this is the CH2 group we are talking about here, and its adjacent carbon has the 3 hydrogen, that means this CH2 group should have some special substance here present. Okay, let's see. Let's go back to the data booklet and see. And also regarding this big hump, we are not sure what should be here, but we know there's a nitrogen there. Okay, now let's go to the data booklet. Let's go to the data booklet and see if we have anything of such. So here we have, let's see, nitrogen. Where should we find a nitrogen? A nitrogen is over here, 1 is here, but see, this is in region 1 to 5, but our hump is in between region 6 to what? 6 to 7. This could also have been a possibility, but this is from 3 to 6, not from 6 to 7. So these are eliminated. This can't be the case. Is there anything else? Yeah, this is a possibility, isn't it? See, this is from 5 to 12, and our region is 6 to 7, which is in the region 5 to 12, isn't it? If this is 5, this is 12, and this is 6, this is 7, isn't it? They're in the middle of this region, like in between this region. So yeah, like that means it might be that it is an amide. Okay, that might be an amide. Let's see if this is an amide. Does that make sense? Yes. And one more thing, we know that we got to know that in the region of 2 we got a quartet. That shouldn't be just a simple CH2. There should be some other group in between. Like in that region we have what? We can have this as 1, isn't it? Because C 2.2 to 3, that is in between our region. So that means CH2C double bond O is a possibility. Let's see if that's the case or not. We must have an amide, isn't it? We must have an amide. So let's say we are just assuming that this is CH2, this is CH2. We should have a C double bond O here. We are assuming because the region, like what if this is the portion which is in between 2, this one, this second one, that means the adjacent carbon has 3 hydrogen, which gives us a quartet. So there is a possibility here, okay? And we should have an amide. Amide means what? NH is like CONH. So this is our CONH group, isn't it? So CONH group, that gives us a region of in between the 6 to 7. And this nitrogen should have like 1 more hydrogen. If it should have 1 more hydrogen, then this is a possibility. And let's see, that means 1, 2, 3, 4, 5, 6, 7. So far what we can observe that this hydrogen should be actually, like Y should be number 7. Like so far what we are concerned about, we can say. Now let's see if this is the case. Here we have a chemical environment. Here we have another chemical environment. However, here we have another chemical environment due to this amide linkage. Remember, there are 2 groups here present. One is this amide, another is this CH2CO group. Okay, so we have 3 chemical environment. However, is the other way possible? Like, is this one possibility? Once this also came in my mind, like, is this a possibility? Like, was this a possibility to have occur? But see, here we have 1 chemical environment, here we have 2nd chemical environment. Here we have another chemical environment, which is the, let's say, or not it as a whole. This as a whole is a chemical environment, which is this amide. However, here we have what? An aldehyde. And if we go back to our slide, let's see, just a minute. CH double bond O, we have an aldehyde present or carbonyl. See, there is a possibility that that's an aldehyde. So aldehyde will give a separate environment. That means what? We would get 4 environments in that case, but we need what? How many environments? We need just 3 environments. That means we are fine with this one we have, okay? So that means the final component is, this is our final component where C is 3, H is 7, and NO, that means X is 3 and hydrogen is what? 7, okay? Got it? So that's basically it. Now moving on to the next example. So before moving on to the next example, I hope you understood like for which region is for which one. So this is for the amide, which is like C double bond O NH, this group, okay? For this group, this is the hum, and this is the environment. For this one, this is actually COCH2, this group, okay? And finally, we have this one, which is because of the CH3 group, okay? So these are the 3 groups for whom these countings are, or these results are, the peaks are present, okay? Now moving on to the next question, we have a similar sort of question. So let's say we're given again a graph. At the same time, we are said that CXHYO2 is a component molecule. And from here, we should get 0, 1, 2, 3, 4, 5. And here we have a group here. Here we have a group here. Here we have a group in this region. Okay. And they have mentioned this is for hydrogen 2, for 3, for 3. Now your duty, before doing that, M(m) plus 1 is given as well. I always forget to give this value, 0.66. So these are the values which have been given to you. Now your duty is to find or attempt at least for once, okay? Because we will be continuing in our next part of the video. So before going to the next lecture, like before going to the next video, it's your duty to try to attempt to solve it, okay? Try it yourself, give full confidence and full effort. Try for the next half an hour solving this question. If you are solved it, very good. If you didn't solve, that's also completely fine. We'll be solving it together, okay? See you in the next video.